Good morning, everybody. Hope you guys had a great weekend. The weather was beautiful. So we're going to be starting the last section of solving systems of equations, but we are going to be using algebra instead of graphing to get the point of intersection. So there are two different ways of doing this. One is called the elimination method and one is called the substitution method. We are going to start with the elimination method. Within the elimination method, you could use addition or subtraction. So today we're going to concentrate on adding, and tomorrow I will introduce the subtracting. So let's take a look at these steps, and then we'll take a look at the first problem. So when you use the elimination method to solve, step number one for today is to add the equations together to eliminate one of the variable terms. You are going to notice in all of the equations today that you have opposite terms. So remember, opposite terms can cancel out to equal 0. So you might have something like 4x and negative 4x. If I add those together, that equals 0. If you have something like positive y and negative y, that also equals 0. And same thing for negative 2x and positive 2x. So you'll see that once we get to the first problem, what we're talking about. Once we add our equations together, we will now only be left with one variable. So step number 2 is to solve for that variable that still remains in the equation, and we'll use inverse operations to do that. Step number 3, we're going to choose one of our original equations, and whatever value we found in step number 2, we're going to substitute that value in, and that's going to allow us to do step number 4, which is to solve for the remaining variable. So let's take a look and see what all of this means. So here is our first example. So notice we have two equations, and both equations have an x and a y in it. So in order to solve for both variables, we're going to have two equations. So we said earlier, our first step is to look for the variable terms that we can cancel out because they're opposites. So we have 4x and 1x. Those are clearly not opposites. But we have positive 3y and negative 3y, which are. So essentially what we're going to do is we're going to add these two equations together. Positive 3y and negative 3y equals 0. So I'm going to cancel them out. I'm going to keep in mind I have an imaginary 1 as my second x coefficient. When I add 4x plus 1x, I'm going to get 5x. I'm going to bring down the equal sign. And if I have a positive 11 and a negative 31, that's going to give me a negative 20. So that is the equation that I'm left with. That brings me to step number 2, solve for the variable that still remains in the equation. So at this point, I can solve for x by dividing both sides by 5, and that's going to get me x equals negative 4. So I found one of the two variables I need, but I still now need to solve for y. So that brings us to step number 3. Choose one original equation and substitute in the value you found in step number 2. It doesn't matter whether you choose 4x plus 3y equals 11 or x minus 3y equals negative 31. It doesn't matter, you'll get the same answer either way. I personally would choose the top equation because there are no negatives. I always know with negatives, I'm bound to possibly make an error somewhere. So I'm going to just take this first equation, 4x plus 3y equals 11, and I'm going to substitute in the negative 4 that I got for x. So now I have 4 times negative 4 plus 3y equals 11. I'm going to simplify by multiplying 4 by negative 4 to get negative 16. I'm going to recopy the rest of the equation, and now I have a two-step equation to solve. So first step would be to add 16 on both sides. And my last step would be to divide both sides by 3. So I get y equals 9. So if I were to graph these two equations and use the slope-intercept method instead, I know my two lines would cross at negative 4, 9. The same solution that I just got solving algebraically, I would get graphically as well. Okay, let's take a look at another problem. In number 2, I have x and negative x. I have 2y and 2y. So x and the negative x, those are my opposites. So when I add my two equations together, those are the variable terms that are going to get canceled out. When I add 2y plus 2y, I get 4y, and 8 plus 20 is 28. I'm now going to do step number 2, and I'm going to solve for the variable that I have left, and I wind up getting y equals 7. I'm going to go back up to the top. I'm going to choose one of my two original equations. So I'm going to pick the top equation. x plus 2y equals 8. And I'm going to substitute in, what I got for y. Okay, so I have x plus 2 times 7 is equal to 8. X plus 14 equals 8. And to solve for x, we have to subtract 14 on both sides. So I wind up getting x equals negative 6. So I have y equals 7 and x equals negative 6. So my solution is negative 6, 7. Okay, let's take a look at number 3. So if I take a look here, looking at the x terms and looking at the y terms, hopefully you're now starting to recognize which are my opposites that are going to cancel out. So in this case, it's going to be the y's. Don't forget I have an imaginary coefficient of 1 for that x in the second equation. When I add 3x and x, I get 4x. And when I combine negative 3 and 15, I get 12. I'm going to solve for x, and I get x equals 3. And now I'm going to pick one of the two equations. And when I look up top, I like the bottom equation a little bit better. The numbers are smaller. I have all positive values. So I'm now going to substitute in the 3 that I found for x, and I'm going to solve for y. So we have a two-step equation. I'm going to subtract 3 on both sides. And when I solve for y, I get that y is equal to 6. So if I had graphed these, my solution would be 3, 6. So whether you solve it algebraically or graphically, you're going to get the same x and y value, the same exact solution. All right, let's take a look at one more. Okay, here, if I look at my x terms and my y terms, I can see positive y and negative y will cancel out. I'm going to add my x's together. I'm going to add my constants on the other side of the equal sign together. I'm going to solve for x, and I get x is equal to 11. I'm going to pick one of the equations from up top. I'm going to take the x minus y equals 5 and substitute in 11 for x. So I have 11 minus y is equal to 5. Some of you might already see what the y value should be. You might recognize it's going to be 6. But if not, I'm going to subtract 11 on both sides. And then finally divide both sides by negative 1, since I have an imaginary negative 1 as my coefficient for y. And I get y is equal to 6. So my solution is 11, 6. Remember, if you're asked to write the solution as an ordered pair, we always want to put the x term followed by the x value followed by the y value. Okay, so that is using the elimination by addition. On the worksheet that I attached to the Edmodo page, there are 4 examples for you to try on your own, and I will send out those solutions later on this evening. Okay, if you have any questions along the way, just ask. You know what, actually, before we go, one other thing I wanted to point out, and let's see where I have some room to do this. Why don't I go back to number 1? If you ever want to make sure, and I'm just going to erase this for a second, negative 4, 9. If you ever want to make sure that your solution is correct, you can always do a check, just like we did in the graphing. So if I have one original equation that I recopy and I substitute in negative 4 and 9, negative 4 for x and 9 for y, I can do a check and make sure that the two sides come out to be the same. So it works for the first equation, and then I can do the same thing for the second equation. I showed you guys this with the graphing, and the same holds true with the algebra. If I substitute in negative 4 for x and 9 for y, and simplify both sides work out to be negative 31, so that's my check. So if you ever want to make sure that your solution is correct, you can always go back to your 2 original equations, substitute the x and y values into both, do a check, and make sure that both of your checks work. All right, so good luck with the problems. Again, if you have any questions, let me know. Have a great afternoon, and I will talk to you